Chris here from the Oracle Mobile Platform team. Okie dokie, iOS programmers still with us? Now, in the last video for you guys, we wrote a very vanilla iOS app to work with geofences, and we hard-coded the latitude, longitude, and radius to represent the geofence. What we're going to do in this video is explore how MCS location-based services can be used to remove that hard coding to make your application much more interactive. So again, let's work with my favorite real use case moving forward and return to my favorite example of Chris's Emporium of quality knickknacks. Okay, so our CEO, that's me, has decided rather than just relying on beacons to capture customers' attention if they're in proximity to our store, it would be great when a customer travels within 1,000 meters of one of our quality knickknack stores to display a message to the customer to remind them they really should pop into our store. And by the way, just to entice them, would they like a 10% discount to get or to buy some of our quality knickknacks? To support this scenario, let me again define a place in MCS entitled Chris's Emporium. Now, once created, we then enter the latitude and longitude of the store. Then we can define the geofence, either as a radius expressed in meters around the latitude and longitude we just defined, or a multi-sided polygon where we define the latitude and longitude of each vertex of the polygon. For the purposes of this video, and again continuing on from the example in the previous video, we'll stick to a geofence based on a radius. Alright, so now we're going to return to our sample iOS geofence application from the previous video, where you'll remember we hard-coded the geofence latitude, longitude, and radius values. So instead, what we want to do in this video is we now want to derive this data from MCS using the MCS iOS SDK. Okay, what we first need to do with our previous application is add the MCS iOS SDK. Now, I've already done that in this application, and I've covered that in other videos, so I'm not going to cover that again. Just refer to those other videos. Once we've added the MCS iOS SDK, then in code, we then need to first get a handle on our OMC mobile backend and also authenticate the user. For demo purposes, to keep it simple, I'm just going to authenticate anonymously, but a real application would likely authenticate a real mobile user against the mobile backend before proceeding. Now, we want to remotely query the MCS location-based services REST APIs. As we've seen previously, if we look to the MCS user interface, we can see that it supports a number of different endpoints, such as querying places, assets, and devices. However, thanks to the MCS iOS SDK, we don't need to make raw REST calls from our mobile application to MCS. Rather, we can use the modules provided by the SDK to do the bulk of the work for us. So here, I'm instantiating a OMC location place query object, which will allow me to remotely query Chris's Emporium as a place from the REST endpoint places query. To do this, I need to define the query criteria. As I'm interested in Chris's Emporium, I supply this as the name. The query by the name is wildcarded, so I need to ensure I don't get any other Chris's Emporiums with a suffix from MCS, so I have to limit the results to one and sort by name ascending. Next, we call the async method execute with completion handler that will make the remote call to the REST API places query. Assuming there's no problems with the call, the result of the call contains as a property an items array of OMC location places. Again, I know for my data only one object will return, so I just fetch, in this example, index 0 of the array. Next, as our goal is to retrieve the locations, latitude, longitude, and geofence radius, we call the location address function, in this case returning an instance of OMC location geocircle. What type is returned is actually dependent on what geofence type you define in the MCS place inside the MCS user interface, and you will need to code for this accordingly in your mobile application. With our geofence based on a radius, to retrieve the latitude and longitude from the OMC location geocircle, we need to call the center method returning a OMC location geopoint, which in turn allows us to extract the latitude and longitude values individually. Returning to the OMC location geocircle, we then also extract the radius. With the latitude, longitude, and radius now in hand, we're then in a position, as we've seen earlier on from the previous video, to define a CL location coordinate 2D object, then use this to populate our CL circular region. Then if we start our app, start monitoring, and via the iOS simulator, custom location options, change the values for the latitude and longitude, you can see the app responding as we enter the new geofence circular region. Of course, these messages aren't very inspiring and are hard-coded into our app too. So potentially we'd rather store the messages in MCS where they can be dynamically changed, and the app can just use these rather than using the hard-coded messages. To define a custom message, we can open our place in MCS and add a custom attribute with a key value pair representing the message to retrieve and the text of our message. Returning to Xcode to retrieve the message in our code is a simple change. First, the OMC location place object via the attribute from key method allows us to retrieve our custom attribute from MCS. Now, the associated value we want to show in the delegate class, we'll write it to a new property in the delegate called enter geofence message. And then we'll just refer to the property in our show alert in our did enter region method. And returning to the iOS simulator, when we run our app again, through the same scenario we just saw previously, this time you can see our custom message being downloaded from MCS and now being displayed in the application. There you go. Overall, working with geofences and beacons is a breeze with the MCS iOS SDK. And the fact that you can remove that unnecessary hard coding in your app, put all of those beacon and geofence identifiers up in MCS, allow your applications to dynamically load it without having to redeploy the application. This is a major benefit. Okay, hope you enjoyed this video. Catch you in the next video very soon.